before I go on to this part, there are a few trigo identities that you must know. Okay, number one is, and this is not given in your formula sheet, sine square A plus cos square A is equals to 1. This is the first trigo identity you learn in secondary school, and this is now not given in your formula sheet. So with this is actually useless. Most of the time we say that sine square A is equals to 1 minus cos square A as well, or cos square A is equals to 1 minus sine square A. So when you see sine square and cos square, these are the first two that comes to your mind. Okay, but not all the time. And this is where not all the time is going to happen. The number two thing is the cosine double angle formula. And this is given. Is equals to 2 cos square A minus 1. It's also equals to 1 minus 2 sine square A. And there's a third one, which is not going to be relevant in this part. Yeah, this is the second time when you see cosine square, this is the second thing that comes to your mind, is the double angle formula. So when you need to integrate cosine square, ask yourself, can I integrate cosine square? Do not confuse yourself with the first part where, it's the integral of sine x cos to the power of 4x dx. Okay, in this case, I need to put a negative first, because this case is the integral of, this is f prime x, this is fx to the power of n. Okay, if you still don't know what I'm talking about, please go back to video 1. Okay? This is a result of when I differentiate a chain rule, the sine x is on the outside because of the differentiator of the inside. And this is just going to be equals to negative cosine to the power of 5x over 5 plus c. If you still don't know how I got from here to here, please go back to review video 1. Okay, so when I want to integrate cos square, I cannot say that it's equals to integral of 1 minus sine square. I can't, because I still need to integrate 1 minus sine square, and I'm not going to get anywhere. Okay, and don't just raise the power and divide by the differentiator. It doesn't work for this case. It can only work if inside is ax plus b form. So this is not correct. Okay, so to get this, I must use the double angle formula that is over here. Cos 2a is equals to 2 cos square a minus 1. This means that cos square a, I make cos square a the subject, is equals to cos 2a plus 1, whole thing over 2. Now I can put this inside. Okay, so this is the same integral. The half put on the outside, cos 2x plus 1 dx. And that will just be your final answer, half. Integrate cosine is sine 2x over 2, plus integrate of 1 is x plus c. Expand it out just to make it nice. Okay, so when you see integral of cos square, integral of sine square, have to think of double angle formula. Cos 2a. There's no shame on writing this on the outside, because I also always write this. Make sine square a the subject, is equals to 1 minus cos 2a over 2. So this is the same as half. Integral of 1 minus cos 2x. Half. X minus sine 2x over 2. Okay, plus c. Expand, okay, to make it nice. Now sometimes you may see an integral of cosine cube and cosine to the power of 4. So for d and e actually is given, so you don't have to work it out yourself. So I'm just going to talk about the integral of cosine cube and cosine to the power of 4, or even sine cube. Okay, but it doesn't matter. The thinking process has to be this way. That means when you see cosine cube, the first mathematical instinct that you have is to break it up to become cosine square x times cosine x first. This is when you apply. Now, when I ask most students, when you see cosine square in this case, what do you think of? They say double angle formula. But you can't do that right now because cos square is not alone. You see, you have to use 1 minus sine square in this case, okay, to multiply by the cos x dx. You can't apply the double angle formula here because that will change the angle to become 2x, and you can't integrate a product if the angles are different. So when I expand this, I'm going to get cosine x minus sine square x cos x dx. And actually, let's split this cosine x. Is this easy to do? Yes. Minus the integral of sine square x cos x dx. This would be your skill number 1, where this is fx to the power of 2. Differentiate sine, what do I get? Cosine, right? Which happens to be f prime x. What is the integral of f prime x, fx to the power of 2? Okay, integrate cosine, this would be just sine x. Integrate of this would be fx to the power of 3. So this will be sine cube x divided by n plus 1, 3 plus c. So whatever that happened in front, you must be very good at it before you can come to here, because there will be many multiple cases where you are going to use. So this is for cosine cube. It can also work for sine cube. So when you see cosine cube, sine cube, think of splitting it up to square multiplied by one of them. But what happens if it is cosine to the power of 4x dx? Same thing. We are just going to split it up to cosine to the power of 2x multiplied by cosine to the power of 2x. Again, this is not the time to apply the double angle formula. But actually, if you do that, it might be possible, but it's just that the working is longer. Integral, let's change this to become 1 minus sine square x. So all these are experiences and exposures that you have to know. Okay? When you expand it out, this will be integral of cos square x minus dx. I'm going to split it now, minus the integral of sine square x cos square x dx. Okay? Well, when I integrate this is where I think of double angle formula, because it's just cos square alone. Okay, so if you have followed just now, cos 2a is equals to 2 cos square a minus 1. So which means that cos square a is equals to cos 2a plus 1 over 2. So this is where you write half integrate cos 2x plus 1 dx. So this is for this part. What about this? When you see sine x and cosine x together, the thing that must come to your mind is your sine double angle formula, which is given. This is 2 sine a cos a. Okay, if I make sine a cos a the subject, it's just going to be half or over 2 sine 2a over 2. Alright, so this is the integral of sine x cos x bracket square dx. Can I apply this inside? Yes, I can. So I'm just going to write half integrate cosine, this will be sine 2x over 2 plus x, and then this will be the integral of sine 2x over 2 bracket square dx. And this actually becomes another integral of sine square. I'm just going to bring this up. You can expand this first, sine 2x plus half x. Okay, minus, this will be 1 over 4 integral of sine square 2x. So whenever you see sine square alone, think of the cosine double angle formula, which is 1 minus 2 sine square a. So sine square a is equals to 1 minus cos 2a over 2. In this case, the a is 2x. Can you see? That's on the left side. So the right side must be a double angle formula. This you just continue writing. The next step will be change this to 1 over 4, the integral of 1 minus cos 4x over 2 dx. Bring the fraction out. I will have, okay, just continue to write whatever is over here, minus 1 over 8. Integrate 1 minus cos 4x dx. Integrate this, I'm going to get 1 over 8 x minus sine 4x over 4. Okay, that's where your plus c comes, and then you are going to write everything nicely. Sine 2x plus half x. Okay, combine the half and the 1 over 8, you're going to get 1 over 4 sine 2x. Half minus 1 over 8, that will be 3 over 8x, and then plus 1 over 32 sine 4x plus c. Okay, so this would be longer. If you see something like x to the power of 4, please pause it to make sure you understand every step that I am doing.